Hello everyone, welcome to my YouTube channel. Myself Samiksha from Sri Venkateshwara College of Engineering. Today I will explain about the corrosion and also types of corrosion. So first, what you mean by corrosion? Corrosion is a natural process of deterioration or loss of metals or alloys through the surrounding environment or electrochemical reactions is called corrosion, or it typically involves the formation of oxides or other compounds on the metal surface. It's weakening its structural integrity and aesthetic appeal. Example for the corrosion are rusting of iron and also green scales formed on copper vessels. So these are the example for the corrosion. Next we move on to the types of corrosions. So there are four types of corrosion: differential metal corrosion, differential aeration corrosion, and also waterline corrosion and pitting corrosion. So first, differential metal corrosion. It means when two dissimilar metals are contact with each other and exposed to the corrosive environment. The metal having a lower electrode potential act as anode and undergo oxidation and gets corroded, and other metal with having a higher electrode potential act as a cathode and undergo reduction, and it's protected from the corrosion. So this type of the corrosion is called differential metal corrosion, and also differential metal corrosion also called galvanic corrosion. In this type of corrosion, the rate of corrosion depends mainly on the potential difference between the two metals, and there is anode and cathode reactions, and also reduction reactions takes place depending upon the rate of nature of the environment. Next, example for the differential metal corrosions are tin coating copper vessels, and also steel pipe connected to the copper vessels, and also bolt and nut made up of the different metals. So these are the example for the differential metal corrosion. So next we move on to the differential aeration corrosion. So differential aeration corrosion means when a metal is exposed to the different concentration of the air or oxygen, part of the metal exposed to the lower concentration of the oxygen becomes the anodic and undergo corrosion, whereas the other part of the metal exposed to the higher concentration of the oxygen or becomes cathode and remains unaffected from the corrosion. So this kind of the corrosion is called differential aeration corrosion, and there is anodic and cathodic reactions. Fe is gives rise to Fe2 plus 2e electron is the anodic reaction, and 2H2O plus O2 plus 4e electrons gives rise to the 4OH minus. This is the cathodic reaction. And example for the differential aeration methods are iron rod partially immersed in a sodium chloride solution. It means iron rod partially immersed in a sodium chloride solution. When the metal immersed in a sodium chloride solution exposed to the lower concentration of the oxygen acted anode, and it is affected from the corrosion, or other metal outside the sodium chloride solution act as a anode cathode, and it is unaffected from the corrosion. And other example for the differential aeration corrosion is part of the nail inside the wall undergo corrosion. So these are the example for the differential aeration corrosion. And next we move on to the waterline corrosion. This is the type of the differential aeration corrosion. So it is observed in a steel or iron water tank partially filled with the water. So when a steel tank is partially filled with the water for a long time, the inner portion of the tank below the water line exposed to the dissolved oxygen. When the portion below the water line is exposed to the more oxygen, the portion below the water line act as an anode and undergo corrosion. The upper portion act as a cathode, and it is unaffected from the corrosion. And also a distinct brown line is formed just below the water line due to the deposition of the rust. And there is anode and also cathodic reactions. These are the example for the waterline corrosion. Means ships which remains partially immersed in the sea water for a long time, and it is affected by the corrosions. And next we move on to the pitting corrosion. So pitting corrosion is the type of the corrosion is observed when the dust particles or oil drops deposited over the metal surface. So pitting corrosion results when the portion of the metal covered by the dust particles or oil which is less aerated and becomes the anodic undergo corrosion and form the pit, and the remaining area of the metal which is exposed to the higher concentration of the oxygen and becomes the cathodic and it is unaffected from the corrosions. So and these are the anode and the cathodic reactions are there, and these are the example for the pitting corrosions. Thank you everyone.